Hi guys, a couple of you have asked me for help on question 6 and question 8 of the sine and cosine rule worksheet that I set for you on Monday. I've just made this video just to help try and explain it. I know those questions are quite difficult. It uses a number of different topics. You've got bearings in there, you've got angles in parallel lines, and then obviously you've got your sine and cosine rules as well. So hopefully these two explanations will just help you as I work through my model answers that I've done for you. Okay, so looking at question 6, you're told in the question that two ships leave a port at the same time. So first thing I did was to draw on the port. I'm told that Darling Dave sails at 12 knots on a bearing of 55 degrees. So just a diagram from your north line, a bearing of 55 degrees of 12 knots. It then says Mary Mary sails at 18 knots on a bearing of 280 degrees. So there's my bearing of 280 degrees, and Mary Mary travels at 18 knots. I can then see that when it asks me how far apart the two ships are after an hour, that must be this pink line that I've got here. So what I just did is I drew a triangle, and I drew that triangle. I added the 55 and the 80. Now I got this 80 by doing 360 minus that 280 to get me what was left over, and that 135 is the 80 plus the 55. Once I've got that, I can just use my cosine rule to find this length. I've got P, capital P and little p here, capital M, little m, capital D and little d. Basically you could swap those for A, B and C if you wanted to. It doesn't really matter, and that's what I've done there. I've just used the formula, substituting the values that I've got in my triangle here, and that's how I got that answer. So hopefully that makes a little bit of sense as to how I got that one. Now looking at part B, I've got that triangle again that I drew previously, and I showed you how I got the 80 and the 55, the 18 and the 12. Now this part of the question asks what the bearing is of Mary Mary from Darling Dave. So what that is we know that this is Mary Mary, and we know this is Darling Dave, and therefore the bearing must be all of this around here. So what I can do is, using my angles in parallel lines, because these north lines are parallel, I know that this is 55 degrees, and therefore this blue bit here, which takes me from the top of my north line all the way around to the line where Darling Dave is, I know that that's 125 because these are co-interior angles, and therefore 180, take away the 55 here, leaves me with 125. Now what I need to do is I need to work out the value of this angle, because what I can then do is work out the value of the orange part, which is the blue part, take away the green, and once I know that orange part, I can just take that away from 360, which will give me my leftover bit of the bearing. So to find the value of the green part that I drew, just showed you above, we've worked this out from part A, and that's my value that I got previously. I'm just going to make sure I use the full value. I use a sine rule because I have got this pair of opposites, the capital and the lowercase. I've got the capital or the angle and the lowercase here, so I'm just going to use my sine rule to work out what the value of this angle here is. Once I know the value of this angle, as I said from here, I need to work out what the orange bit is. The blue bit, take away the green bit, gets me the orange bit. So that's what I've just done here. 125, which was the blue, take away that green angle that I just worked out, gets me this value here. The bearing, as I said, which is this red part going all the way around in a clockwise direction, is 360 minus the orange part, which I've worked out here. And therefore, that's how I get that value of 262. Hope that helps. Okay, looking at question 8 then, we're given the example in the question. The first thing I did was to work out the value of this 126. To do that, I used co-interior angles of up to 180 degrees. So 180, take away that 54, got me the 126. I then used angles around a point to work out this 86 degrees, because all of these are around 1 point. So I just did 360, take away 148, take away 126, which got me the 86. I then used the cosine rule to work out that length x, because the question asked for the direct distance between h and p, therefore that's that length there. There's your cosine rule, just substituting the values. You may need to just cross out the letters that are already on there and add in your A, your B and your C if you really wanted to, if you weren't too comfortable with H and P. But other than that, it's just a simple cosine rule there. For part B, it asks for the bearing of H from P. So what I did is I drew myself another diagram. The bearing of H, I didn't label it on here, sorry, so that should be H there from the diagram above. And the bearing, like I had before, is this angle here, because I want the bearing of H from P. So how do I get from this north line all the way around to the line where H is? Again, co-interior angles add up to 180 degrees, so I just did 180, take away that 148 to get me that value. And then I worked out my value of P using the cosine rule here. So cos P is 14 squared plus 16.6 squared minus the 10 squared, all in the diagram, and just worked out that value of P. I knew the bearing was 360 degrees, the whole lot of it. Take away the 32 and take away that value of P that I worked out there, and that gets me that bearing. Again, I hope this has been helpful for you to understand these style of questions.